students. Today's topic of our discussion is a projectile motion. Now, any motion in a plane under a constant acceleration is called projectile motion. This is the general definition. Okay. Definition specific to your chapter, what we are studying, it's a motion in a plane, is any motion in a plane under no acceleration other than gravity is called projectile motion. That means, suppose this is the ground, you throw a stone with some particular velocity at some particular angle, then it will go and fall back to the ground. Now see what kind of a motion is this. All the time earth pulls it with a force of mg. So under the acceleration due to gravity or under the gravitational force only it is moving all the time, right? This is a projectile motion which is specific to the definition what we are studying right now, and we'll study various type of projectile motions. You may throw a stone at different angles. If you throw it at 90 degree, it will come back to the ground again. So at different angles you may throw a stone, or you may fire a bullet, or from a certain height, from a tower, let us say, of object of mass m be thrown with a certain velocity, and then that will also travel, that will also make a projectile motion before hitting the ground. So various types of things we will be seeing according to this. All these are categorized into the class of a projectile motion. So suppose you are throwing a body of mass m with a velocity u, and when you throw, once it leaves your hand, it is in air only, right, till it reaches some height, maximum height, then coming back to the ground. Now few things here we should understand related to the projectile motion. The velocity with which it is thrown is called velocity of a projection. The theta, the angle with what it is making with the horizontal when it is throwing, is called angle of a projection. Before hitting the ground again, how much horizontal distance it has traveled is called horizontal distance or horizontal range, and we denote that by a symbol R. So I am writing capital R for range. What is the maximum height it reached before coming to the ground again? So it is rising to a certain point, it is rising, and after that it is coming to ground. So if we will measure only the height from the ground, the height is increasing till a particular point, and after that height is again decreasing. So the maximum height traveled, maximum height reached. So we will write it capital H is maximum height reached, and for what time the bullet or the stone, whatever you say, for what time the stone remained in air from here till it hits the ground again. How much time it remained in air is called total time of flight, and we mention that as capital T. Let us say this point is A, and at the point where it hits the ground is B. So it travels like this, O to A to B, it reaches here. So this path is called, this path in which it covers is called trajectory. It is making two types of a motion at the same time. One is it's also moving horizontally, it is covering some range, right, and it is also moving vertically. At any point you find along horizontal also it is traveled something, along vertical also it is traveled something. So at all the point it is having two types of a motion, that is clear, horizontal motion also, vertical motion also. Now we will derive these things mathematically. Let us say this u is resolved into two components. One is a horizontal component, one is a vertical component. Clearly what we can say, this is u sine theta, this is u, so u sine theta, and this is u cos theta, right? Now see, theta, u sine theta component is subject to the acceleration due to gravity all the time. Earth is pulling this object downwards all the time, right? So u sin theta, because the effect of the gravitation, downward gravitation, u sin theta gradually decreases. Finally, a point comes where the vertical component of the velocity becomes 0. After that, again it increases but in the opposite direction. So the vertical component of the velocity is always changing throughout from O till it reaches B, it is changing. However, the horizontal component of the velocity is not impacted by anything, because there is, according to the definition, if it's a projectile motion, there is no other effect than gravity, and gravity is at 90 degree. When it was traveled from O, the horizontal component of the velocity was u cos theta only, and when it hits again the earth at point B, then also horizontal component is u cos theta only. That means along x direction the velocity is not changing, however along y direction its velocity is changing all the time. Let us say this is our x axis, so this is x direction, we will say this is the y axis, y direction we will say. Fine. Now, if we want to find out the time taken in which the body has traveled from O to A, how we'll get that? If we consider only motion along y-axis, since this is a constant acceleration case, so we can apply the equations of a kinematics all the time. And what are the equations of a kinematics? V is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. You know the fact that these are all vector quantities, and these can be applied any time where any motion where the velocity is changing from something to something with a constant acceleration. Motion along y-axis we are considering. Let us apply the first equation. V along vertical direction, finally the initial velocity along vertical direction was u sin theta. So I am writing u is equal to u sin theta. That means u is, in this formula, what is u is meant by initial velocity is equal to u sin theta. Initially it was u sin theta, and the final velocity was 0. V is equal to 0, right? So from O to A, so this was at O, right? And this was at A. So from O to A, traveling, how much time it required to reach there? How we can find out? Apply this one. Final velocity is equal to, that is 0 is equal to u, initial velocity, that is u sin theta, plus at. A is equal to how much? Minus g. Now see, we are seeing in this direction. In this direction it is moving, and gravity is in downward direction. That means it's in the opposite direction. So acceleration is equal to minus g. So v, final velocity 0, is equal to u sin theta plus at, plus a, that you can write directly minus g t, where t, small t, is the time which is required to move from O to A, or to rise this much height, how much time it will take. From this, what we can conclude? Gt is equal to u sin theta, implies that t is equal to u sin theta by g. Let us call it equation 1. Now we are going to find out what is the distance traveled within this much time. If we can find out the distance traveled along motion along, while studying the motion along y-axis, what is the distance traveled in t time, if we will calculate, that is nothing but the maximum height reached, yes or no? So what we will do, the y, the distance traveled, or I am writing directly h, I am going to apply s is equal to ut plus half at square. S is nothing but the maximum height reached, so h is equal to, I have taken ut, initial velocity multiplied by the time. Initial velocity is u sin theta, multiplied by time t, how much is required, and how much is required to reach A, that we have calculated already. So from equation 1 I am writing it here, ut, t is u sin theta by g, h is equal to ut plus half at square. Now again a is a minus g, I am writing, so minus half g t square, square of this u square sine square theta by g square. Here, now this is g square means g into g, so 1g got cancelled with 1g. So this is u square sine square theta by g minus u square sine square theta by 2g is equal to how much? U square sine square theta by 2g. So we got the maximum height reached is equal to u square sine square theta by 2g. So what result we are getting of these three important things, what I said, the total time of a flight and horizontal range and maximum height reached, these three we are basically going to find out. So one we got already, so let me write that. H is equal to u square sine square theta by 2g. Now we will see from O to A while traveling how much time is taken, we have calculated already. From A to B how much time will be calculated, that also we will calculate, and we will add this time with this time, so that which will give the total time of a flight. Okay. Now see, since this motion is under the same acceleration due to gravity, how much time is required to reach the maximum height? Same time will be required to reach the ground again. So 2t is the total time of a flight. 2 times of this time only is the total time of a flight. So from common sense we understand that. However, mathematically we are going to derive. So how much time is required to go from O to A we calculated. Like that, how much time is required from to move from A to B we will calculate, and we will add those 2 times. So one is what is the maximum height reached we have calculated. Now we will see to fall that much of a height again how much time will be taken, that we are going to calculate. I am erasing this to make some space, and hopefully you have noted this down already in your note. So to fall this, how much time will be taken? We will consider the vertical motion again, but in this downward direction. So what is the distance traveled? That's s. I am again using s is equal to ut plus half t square, and for the distance h I am writing s is equal to ut. So while falling, it was velocity became 0 and falling, so it is like from rest it is falling, so u is equal to 0 multiplied by whatever time is required, t, plus half g. Now see, acceleration is a plus g because it is moving downward direction, and g also is in downward direction only, so acceleration is nothing but plus g. So s is equal to ut plus half a is g t square. This t is what? How much time is required to fall. Okay, so implies that h is equal to how much we have derived already, u square sine square theta by g is equal to half g t square. Now h is equal to u square sine square theta by 2g is equal to ut half gt square. This half, this 2 got cancelled. Now t square is equal to u square sine square theta by g square. Implies that t is equal to root under this much u sine theta by g. Now let us call this equation 2. In equation 1 we got the time which is taken to reach A. In equation 2 we got the time which is taken to reach from A to B. Now this was also u sine theta by g, this also is u sine theta by g. So total time of a flight is equal to how much? T plus t, 2t, that is 2u sine theta by g. U sine theta by g plus u sine theta by g. So we got another conclusion. Let me write it here. T is equal to 2u sine theta by g. Now we will find what is the range. So simply, what is the range? The velocity, horizontal velocity, we know it is constant velocity. It is not changing because there is no acceleration along x-axis. That much. So velocity multiplied by the time, total time of flight we got already. The horizontal range r is given by u cos theta multiplied by t. The total time of a flight multiplied by this constant velocity, because it started the constant velocity along the x-axis. Velocity, initial velocity was u cos theta, and when it hits the ground also it was u cos theta only. So u cos theta multiplied by t is equal to u cos theta multiplied by t. Just now we calculated, it is 2u sin theta by g. Now we can write it as u square multiplied by 2 sin theta cos theta by g. Now we have one trigonometric identity. 2 sin theta cos theta is sin 2 theta. So I can write that as u square sin 2 theta by g. So the final result what we got is range is equal to u square sin 2 theta by g. So these are the three main things we got already for a projectile. Hope this is very clear conceptually.